Okay. Good morning, students. I'm Pawan Manas, Sunbeam teacher. I'm going to revise your motion chapter, which is a part of physics. So let's start. Okay. The basic concepts of motion. We here study the basic concepts of motion. What is the velocity? What do you mean by position? What is absolute velocity? What is etc. etc. Let's start from here. Okay. Now, what you can say about position is what is position? To illustrate position, I will take an example. Let's suppose four A, B, C, D are sitting in a row equidistant. These are A, B, C, and D from left to right, sitting in a row equidistant from their neighbors from left to right as shown in the figure. Now, what I am going to do is I am just ask the question that position of B with respect to A, C, and D in subsequent manner. So, what is the position of B with respect to A? It is immediate right. There is the A, and to the immediate right of A, B is sitting. Now, subsequently, this C is immediate left of B, C is immediate left, D is the second to the left, and thus the position, what I can conclude from this point is the position is relative, which varies according to the reference point. If I change my reference point to B to D, the position of all these three persons will change. Now, so that now what I can say is position can be relative and absolute position. Position could be a relative or absolute, and this in absolute and relative position we are going to study further. So what is it? Let's take a Cartesian plane where east, west, north and south, and this is O, B, C and D. These are the reference points. Okay. In the figure, position of B with respect to A is position of B with respect to A is that B is sitting in this direction and A is in this direction. It will be eastward. Okay. And with respect to C, that what I am saying is position of B with respect to C, it is in the northeast direction. It is written here. Where? Northeast direction. So, next point is this is known as relative position. That what I said is position of B with respect to A is in the east direction, position of B with respect to C is in the northeast direction. Similarly, I can say that the position of A with respect to C is in the northward direction. Similarly, this type of something that means I am denoting the position of another person, one another person with respect to each other. So this is a kind of a relative position. But in order to consider all points in one frame, we need to consider one point as an absolute referral point. Mark the word absolute referral point. And position of all other points with respect to that point will be there. Now, this is the relative position. Now I am going to talk about the absolute position. Suppose this position O, I take it as an absolute position. So, the position of other four persons, that is A, B, C and D will change. That means what I am saying that, for example, consider O as the absolute point. O as the absolute point. Then position of all other points with respect to O will be their absolute position. For B, it is OB in the northeast direction. For O to A, it will be northwest direction. For D, it is in the southeast direction. These are termed as absolute and relative position. These are very important points in motion. So we can conclude it by saying the two node points. First is we can take any point as the absolute according to our convenience. Here I have taken the point O as the absolute point, but you can also take the point D as the absolute point. And the second one is direction as well as the distance, both is required to denote one's position. Okay, now I am going to give you some homework. These are the illustrative problems. You have to tell me that what is the position of E with respect to D. Here is the E and here is the D. These are the Cartesian plane in which I have drawn it as east, west, north and south. You have to tell me two things. First, their absolute position and their relative position, and for what person you are taking as the referral point, you just have to mention it and show me. Now I am moving further. Concept of rest and motion. What is if a body is said to be in rest, and what if the body is in motion? So I am going to here rest. A body is said to be in the rest position if its position does not vary. Mark the word here. This is the most important line. Rest, that means a body is said to be in the rest if its position does not vary with respect to the time. Why? While talking about the motion, what I can say that continuous change in its position. Just focus here. Position do not vary with time and continuous change in its position. Okay. Concept of rest and motion is related to referral change. Referral change in position. So a single object can be at rest or at motion same time with different referral points. I can give you an example of this one. So here is the example: a person sitting in the train, and here is the window glass. A house outside the train. It will move in the backward direction because the person is moving in the forward direction. For the person sitting in the train can say that the house is moving in the backward direction. That means house is in motion, but actually it is not. So how it is possible? They are doing a kind of a relative motion. It's a direction of passenger's motion, and it's a great example of relative motion. Okay. Now back into the previous slide. If we consider a single object as referral point and consider it as rest as an absolute point, any object which is at rest with respect to that point is considered at rest, and same case with the motion. It can be better understood by the example of Earth. In general we consider Earth as an absolute point. एब्सोल्यूट पॉइंट है हम सबके लिए, तो वो हमारे रेस्पेक्ट में अर्थ स्टेशनरी है, बट अर्थ इज डूइंग द मोशन ऑल्दो इट इज इन मोशन विद रिस्पेक्ट टू सन एंड अदर प्लैनेट्स. सो दिस वाज द कांसेप्ट ऑफ रेस्ट एंड मोशन. नेक्स्ट I am going to talk about the some scalar and vector quantities. These are the three examples whose lengths are L, L and L. The points are denoted by A and B. Just look over it. Okay. I'm here. AB is the point whose length is L. AB is a line segment of length. AB has no specified direction. That means it can be extended up to this side or it can be extended up to the other side. AB is a scalar because it has no specified direction. But while talking about the other point, what I can say is this AB and here AB. Just see the direction. It is in from B to A, and here it is from A to B. So BA is directed line segment directed from where to where? Directed from B to A. The length of BA is L. That means it has the direction from B to A as well as the magnitude of it. It is magnitude L, thus BA is a vector quantity. Same case here. Here the direction gets changed and length of AB. It is directed line segment directed from A to B. The length of AB is I. That is its magnitude is L. Thus AB is a vector quantity. Okay, we have to note here some point. Vector ABA is not equal to vector AB. If direction changes, that means the scalar, that means the vector quantity also changes. That is written here. Vector BA is not equal to vector AB. That means BA, B to A is not equal to A to B. This side. Okay, and their direction are different. Although they are equal in magnitude because both have the same magnitude L. They have the equal magnitude for two vectors. For two vectors to be equal, that means if I have to make this vector quantity, this BA, to equal this BA, I have to place a direction arrow to this side. That means they are moving from where to where? Right to left. This position vector has to also also be changed according to this one, or you can either do vice versa. So for two vectors to be equal, both in direction and magnitude should be equal, since both the vectors are equal in magnitude, but just opposite in direction, we can write a vector AB will be equal to negative of vector BA. This negative sign, here I have written the negative sign. This negative sign shows that they have opposite direction to each other. Okay. Now let's take some example of distance and displacement. Just focus here. Here I have taken a point A and this is the point B. I have to reach from point A to point B. I can take two paths. Either I can go directly straight to point B, or I can take a zigzag motion path. This one, C and D. Via C and D I am going from A to B, or I can either go from A to B. So what is the displacement? Displacement is the shortest distance between the 2 points. Here my initial point was A and the final point is B. So I have taken the shortest path. This is written here. In the figure there can be a various paths. Either you can go this way, either you can go this way, or you can go from the other side of the board. Whatever the path you follow, that will be the distance. In the figure there can be various paths, but the shortest path I have highlighted it by blue color. Just focus there. But the shortest path denotes actual change in position from initial point A to final point B, which we call as displacement. This blue vector is known as displacement. Okay. Now take the next example. You can go in the either direction. Here was the A, here is the B. You can go from this side to this side. You can go via C, or you can take a circular motion path. This could be example of distance and displacement. Okay. Concept of rate. What is rate? It's a revision class, so I am a little bit faster. Concept of rate. Rate is defined as the ratio of change in two quantities. Rate can be defined as the ratio of change in two quantities, and also it is of two types. First is the average rate of quantity A with respect to B, or net change in A upon net change in B. Okay, there are two types of. First is the average and the second one is the instantaneous. Average rate, that means net change in A with respect to net change in the B. And what is instantaneous? It is the rate at an instant that is for very short interval of time. Speed, velocity, acceleration are example of rate. स्पीड का रेट जितना ज्यादा तेज होगा उतना ज्यादा आपका एक्सेलरेशन चेंज होगा. दैट इज द कॉन्सेप्ट ऑफ रेट. ओके, व्हाट इज स्पीड एंड व्हाट इज वेलोसिटी? एवरेज स्पीड मींस टोटल डिस्टेंस ट्रैवल्ड इन टोटल टाइम टेकन. इन दोनों का आप रेशियो लेके टोटल डिस्टेंस ट्रैवल्ड टू द टोटल टाइम टेकन, व्हाट यू विल गेट एज द एवरेज स्पीड. व्हाट इज द इंस्टेंटेनियस स्पीड? इट इज द स्पीड ड्यूरिंग अ वेरी स्मॉल इंटरवल ऑफ टाइम. That means you have considered for a very short interval of time that speed at that point or that instant is known as the instant speed. What is average velocity? Net displacement. Mark the word displacement here. Net displacement to the total time taken. And what is instantaneous velocity? Velocity during a very small interval of time, and velocity is related to the displacement and thus is a vector quantity. So this was all about speed and velocity, rest and position, rest and motion, and what we have studied is absolute position, relative position. So I think this is the enough for this class. We will meet in short interval of time. Till then, do take care you from coronavirus, and thank you. Jai Hind. Physics revision class. I am from Sunbeam. My name is Mukund Manas Moganwal. Is it clear?